Okay, students. A racemic mixture consists of both dextron-levo isomers in equimolar quantities, which is optically inactive. Between the two, when we need one isomer, either dextro or levo, we need to separate the isomer from the racemic mixture by a simple method. That process of separation of one optical isomer from the racemic mixture is called resolution. Resolve, I mean to say, separation of either plus or minus or both plus and minus isomers from the racemic mixture is called resolution. And resolution can be made by different methods, out of which one or two important techniques are biochemical method. What actually in this method we are going to do is, in biochemical method, after taking a racemic mixture which consists of both plus and minus isomer, we allow a microorganism to grow in the racemic mixture. As the microorganisms are stereospecific in their activity, they consume only one isomer, leaving the other isomer unaffected. But there are a few disadvantages in biochemical method of separation. The first difficulty arises is, suppose when you want to separate the plus and minus lactic acid, we need plus lactic acid and we don't need minus lactic acid. In such a situation, we are supposed to search an organism which has to consume only the minus lactic acid which is not needed to us, and which should not touch the plus lactic acid which is needed to us. I mean to say, it is very difficult to select a microorganism which consumes only one particular isomer which is not needed to us. The second difficulty which we come across in this biochemical method of separation is, in many cases the separation becomes incomplete. I mean to say, whatever the microorganism which is going to consume one of the particular isomer as a food or something, nutrient or something like that, so it keeps on consuming the molecule, and at one particular stage it stops consuming the one particular isomer, where the separation becomes incomplete. So it is difficult to select one particular microorganism which consumes only one isomer which is not needed to us. And the second difficulty is, many cases the separation becomes incomplete. For that difficulty, we are going to use another method, chemical method of separation. In this chemical method of separation, a racemic mixture is going to react with another optically active reagent. For example, let us consider A is an optically active compound, and we have both plus A and minus A in the racemic mixture. For that particular racemic mixture, we are going to add only a reagent which is also optically active. So it is LEVO. So this reagent, which is LEVO, that combines with both plus and minus isomers of the racemic mixture, giving plus A and minus R one particular compound, and minus A and minus R and the other compound. As these two compounds, they differ in their properties, these two can be separated by any physical method, either by fractional crystallization, fractional distillation. Sometimes they can be separated by hand picking method when they are solids, because they crystallize in a different manner. For example, when you take a particular example, when you want to separate plus and minus lactic acid from a racemic mixture, a mixture containing both plus and minus lactic acid is made to react with minus glucine. So that the minus glucine react with both plus and minus lactic acid, giving plus and minus lactate glucine and minus lactate glucine. As these two compounds which are going to be obtained after the reaction of an optically active reagent with the compounds of the racemic mixture, so these two, they differ in their properties. As a result, the obtained two products, they can be separated. After separating, remember, the reagent can be detached by adding another reagent. So this is a brief about your resolution. Okay.